Hello, everybody. Welcome to Build and Deploy a Model with Vertex AI. My name is Sara Robinson. I'm a developer advocate on the Google Cloud team focused on machine learning. You can find me on Twitter at srobtweets. In this session, I'm going to walk you through how to train a custom model, how to deploy that to an endpoint in Vertex AI, and how to get predictions on that model endpoint. If you are registered for this session at Google I/O, you can ask questions using the Q&A feature. And I have some awesome TAs that will be there to help answer your questions. So just wanted to give a shout out to them. Boris, Dale, Mark, and Mikhail, thank you a bunch for answering questions. So anything you have questions on, if something isn't working, if you're following along step by step, just ask in the Q&A. So now to the fun part, we're gonna get into the workshop. What will you learn in this workshop? So yesterday, we just announced Vertex AI, which is our new end-to-end machine learning platform on Google Cloud. Helps you with every step of the ML process from gathering your data, training, deploying models, and managing models in production. So you're going to learn how to train and deploy a custom TensorFlow model on Vertex AI. The finished product will be a deployed model endpoint that you can use to get predictions. So if you'd like to follow along, please head over to the URL on this slide, g.co/codelabs/cloudai-lab. So if you could all go there, assuming you're following along, you can also just watch. I'll be going through all of the steps. I'll leave that up for just a moment so folks can get to that URL. And from there, let's roll to the demo. Great. So if you went to that URL, you should be at a page that looks like this. This is the code lab that will be following step by step. I'm going to go through everything. And you'll want to also have your Cloud Console open in a second tab. You can access that by going to console.cloud.google.com, what you see here. So I'm not going to show the lab. I'll just assume that you have that up. I'm going to be accessing it from another tab. So this way you can focus on the console. So if we look at the overview step in the lab, we'll get started. We're going to use Vertex AI. As I just mentioned, this is our newly announced ML platform on Google Cloud. Super excited to have all of you try it out. We are going to use this to build a custom model. So we're going to build a TensorFlow model, see how to kick off a training job on Vertex AI, and then take the results of that training job, deploy that to a model endpoint, and get our predictions. To interact with most of the tools in this lab, we're going to be using Cloud Shell, which is a command interpreter that is powered by a VM that's running on Google Cloud. The great thing about Cloud Shell is that it lets you interact with all the different products in your Cloud Console. So you can leave the shell window up, click around, and access a ton of different products. The Cloud Shell window also has an IDE. So we're also going to be using the code editor in Cloud Shell to generate some of the files that we're going to be using for training in this lab. One other thing, the cost of the lab, as I mentioned, is about $2. Just make sure you follow the instructions at the end to clean up the resources so that you're not charged, assuming that you don't want to use them after the workshop. So with that, let's proceed to step 2. Quick intro to Vertex AI. So Vertex AI, which we can see in our console. If we go here, just click on the navigation menu. I have pinned it to the top, which you can do by scrolling down to find Vertex under AI, and then just hit that pin button. So I've pinned it to the top, so we can see Vertex AI here. As you can see, Vertex AI includes lots of different tools to help you with each step of the ML process. And you can use as many or as few of those as you want. So if you only want to use it for training, you're welcome to do that. If you want to use it for prediction, you can do that, or you can use it for your end-to-end ML workflow. In this lab, we're going to be focused on the training, models, and endpoints products here in Vertex AI. So with that, we are going to start setting up our environment. So if you don't have a project, I mentioned this before, you'll want to just click on this at the top, and then you want to hit New Project here. You'll give your project a name. It'll just take a few seconds to create the project, and you'll be good to go. And just make sure that you associate that project with a billing account that you've set up. So we are in Vertex AI. As I mentioned, the primary way we're going to be interacting with Vertex is through this tool called Cloud Shell. So you'll want to find this Activate Cloud Shell button at the top of your console, and we're going to click on that. Okay, so we can see we now have access to this command interpreter that we can use to access all of our cloud resources. The first command that you run in Cloud Shell, it'll ask you to authorize it, so you'll want to click Authorize. So just to make sure that we're authenticated correctly, I'm going to run gcloud auth list. If you've never used gcloud before, gcloud is the CLI tool that you can use to interact with many different cloud projects. So we can see that I am authenticated, and this is the project that I want to use for this workshop. If the project you see here isn't the one you want to use, just run, and this is in the lab instructions as well, just run gcloud config set project and then the project ID that you want to use. I'm all set, so I don't need to run that. There is a environment variable that Cloud Shell gives us with our project ID, and I'm going to be using this in several places throughout the lab. So you'll want to run echo Google Cloud Project. That's the name of the environment variable that we get through Cloud Shell. And you should see the ID of your project there. So that means you're good to go. So now that we know how Cloud Shell works, one other thing I want to show you is this handy IDE that I mentioned. Another cool thing about Cloud Shell is that you can expand the window to be as big as you want, and you can click around within your console and the session will stay active. So you can also click on this Open Editor button. This is opening the Cloud Shell IDE. And we're going to be using this to create some files throughout the lab. You can have the terminal and the editor side by side. I kind of prefer just bouncing back and forth between them. So whatever files I create here will be saved if I go to the terminal and vice versa. So I'm just going to be going back and forth between them. Okay, so now that you are oriented with Cloud Shell and the editor that's in Cloud Shell, we're going to get started. So the first thing you'll want to do is you'll want to copy that snippet, which will use gcloud to enable all the services that we're going to be using in this workshop. So you'll run a command that looks like this. This is enabling 3 services for us. Compute Engine, we're going to be using this to run some of our training jobs and when we deploy our model. Container Registry is a place where you can store all of your Docker container images securely and share them amongst different people on your team. We're going to be using that to package up our training code. So one option that Vertex AI provides for training, and I'll get into this more in a moment, is packaging your code as a Docker container. So we are going to package up our code. We're going to push it to Google Container Registry, and then we'll use that to run training. So the last service we're enabling is called AI Platform. That will give us access to all of the different tools that we'll be using on Vertex. I am going to zoom in a bit so that you can all see this a bit more. Hopefully that makes things a little easier to see. Okay, so once this completes, you should see this message, operation finished successfully. The next thing we want to do is create a cloud storage bucket. So Google Cloud Storage is our object storage solution on Google Cloud. We'll be using this to save some of the assets that are created in our training job. So when we run model training, the last step of that training job will be to save those TensorFlow model assets somewhere, and we need to save those into a cloud storage bucket. So we are going to create a bucket, which is what this command does. I have already created this bucket. Buckets across Google Cloud Storage need to be globally unique. So the reason I put this here is that your bucket name is just going to be your cloud project name with /bucket or -bucket appended. So it should hopefully be globally unique. And then you're going to run this gsutil command, which will make the bucket for you in a specific region. I'm using the US Central 1 region throughout this lab. You can use other regions if you'd like. Just keep in mind that you need to keep it consistent, since the region that your bucket is in is also the region that you need to use when you create an endpoint. Let me just make sure that that font size looks good. I think we're good, but let me know if you can't see that. So this GSUtil is the CLI we'll use to interact with Google Cloud Storage. I have already created this bucket, so I'm not going to run this command, but if you run that command, it should create a bucket for you. And then when you go to Cloud Storage, you should see that bucket created. It'll look like this with your project name there. And notice that I'm clicking around to different products here in my console, but my Cloud Shell is persisting. So you should have created a bucket with this bucket name environment variable. And the last thing that we're going to do in this step is we're going to just make a quick alias to make sure that when we run Python scripts throughout this lab, we're going to be using Python 3. So that concludes the setup portion of this. So you should have created a bucket and enabled all the services that we'll be using throughout the workshop. And now we're going to get into the machine learning aspect of this. The model that we're going to be building is we're going to be using a public data set of car data. The data set is called AutoMPG. I'll show it to you real quick. It's available on Kaggle, also provided by UCI Machine Learning. So this just has some metrics on different cars, along with their fuel efficiency, miles per gallon. So we'll be building a regression model, which means that we'll be predicting a numerical value, which will be the fuel efficiency of a vehicle. So that's the data set we'll be using. We're going to be building a TensorFlow model to do that fuel efficiency prediction, but the focus here is mostly on the tooling available in Vertex AI for training and deploying models. So hopefully once you've completed this workshop, you'll be able to take what you learn and apply it to your own data set that you're working with at your organization. So next, we're going to move on to step 4, which is where we're going to get into the fun ML parts of this. So in this step, we're going to be containerizing our training code. To do that, we want to create a couple directories and files that we're going to use to put our training code into a Docker container. So I'm going to run these commands to create some files within a directory called MPG, just calling it MPG because that's what we're predicting, miles per gallon. So once I've created these, I should see them show up in the editor. And I do. So I have this MPG directory. Let me just make this a tad bigger. I have an MPG directory with a trainer subdirectory and this train.py file. The reason I've chosen to use a container for this, to put this all in a Docker container, is because this handles a lot of the headaches of dependency management and version management of all the different dependencies that my training code uses by containerizing them. And I can easily share that with other folks on my team if they want to reproduce my training experience. So we've created all these files. They are currently empty. So you just need to double click on them in Cloud Shell to open each file. So we have this Docker trainer directory, and this train.py file is where we're going to be writing our training code. So the next step is to create our Docker file. The Docker file sets up the commands that will be run when this container is run. So the first line here is, notice that we're using a deep learning container image provided by Google Cloud. So there's many different options to choose from. You can look at the Google Cloud Docs if you want to learn more about what's available there. We're using a TensorFlow 2.3 image. One of the great things about using this image is that it comes with a lot of popular ML and data science frameworks pre-installed. So it includes Pandas, scikit-learn, TensorFlow, along with some others. So then we are going to set up our entry point to invoke our training code, which is in this trainer.train file. So once we've copied that in, we can save that in our Docker file. And the next thing we want to do is we want to take that long code snippet in step 4 of the lab that will contain all of the training code that we want to be run when we run this training job on Vertex AI. So I've just copied that and I'm going to paste it into my train file. So let's just walk through what this does briefly. there's a reference to a bucket at the top. We're going to replace that in a moment. So don't worry about that right now. First, we're just importing some libraries that we're going to be using for training. And I've made a version of this data set public in Google Cloud Storage. So in the next few lines, we're just downloading that data set into a pandas data frame. We're going to just clean up the data a bit, do some feature engineering to make sure that the data is all in the right format that we'd like. Next, we are splitting the data into train and test sets. And this is adapted from a tutorial in the TensorFlow documentation, if you'd like to learn more about it. So we're splitting our data into training and testing, which is best practice in machine learning. You want to make sure that you set aside some of your data to use for testing that wasn't used when you trained your model. The next thing we're doing is, which is really important in machine learning as well, is we're normalizing our data. So when you're dealing with numerical data, often that data can range and have many different values. And so what you want to do is typically normalize that within a common range so that all of your values are within, say, -1 and 1 or 0 and 1. And then we build our model using the Keras sequential model API, which is part of TensorFlow. And so here we're just, the sequential model API lets us build our model as a stack of layers. And remember that this is a regression model, so the output is just a single numerical value. And then we run training. And the final line of code here is going to save our trained TensorFlow model to a bucket in Google Cloud Storage. So if you remember, we had that bucket variable way at the top of the file up here. So now we want to replace that with your cloud storage bucket. So let's do that. So if you go back to the lab in step 4, you will see that there is a little sed command there. So what we want to do is we want to bounce back to the terminal. Let me just make this a little bit bigger so you can all see the terminal code. Okay. We're going to run the sed command. All this is doing is it should replace the bucket name variable with the name of our bucket at the top of the file, which it did. So that's a success. And now we have all of our code ready to go. So the next thing we want to do is build and push the Docker container. So we'll build the container locally, then we'll push it to a container registry. So we'll be doing this back in the terminal. When you run these commands, you want to make sure that you're within the MPG directory, whatever directory has your Docker file at the root. So if you copy that command that sets the image URI variable, when we push this to container registry, this should be, it should use your Google Cloud Project ID as part of your URL, and we're calling this image MPG and we're tagging it as v1. Next, we want to run Docker build. So this will run the commands we've specified in our Docker file. And this might take a few minutes for you if you're following along. Might take about 5 minutes to run. I've already run this a few times, so it shouldn't take that long for me. I'm just going to make this a bit smaller while that runs. So once the build command completes, the next step is going to be to push this to Google Container Registry. And so I'm going to head over to Google Container Registry while this is going. And you can see that I have one version of this here, just a saved version of this image that I'm building right now. But once this build command completes, we will run Docker push with that image URI. And we should then see that appear in Container Registry. So if that doesn't finish up soon, I'll probably just use the saved version that I have. And yep, so after this, you will push this image to Container Registry. Again, if you have any questions or running into issues, just use the Q&A feature to ask a question to any of our wonderful TAs. And so once our Container Registry image is available, we can then point Vertex AI to that image to run training. If you prefer not to work with containers, you can also package up your training code as a Python package, and you can provide your custom training code to Vertex AI that way, if you'd like to do that. So a couple different options for training. I'm just showing you one here. You can also take advantage of AutoML for training your models. So while that's running, I'm just going to pop back over to Vertex AI and show you where we'll kick off a training job. I'm going to make this just a little bit smaller so that you can all see. So you should all be able to see the training section of the console in Vertex AI. So once this is ready to go, we will click create to create our training job. We will tell Vertex the URL of this container in container registry, and then we will be ready to go. So because this is taking a bit, I'm just going to use a saved version that I have of this image. So I'm going to go over here to create. Just remember, once your Docker image finishes the build step, you'll just want to push it. So there's a command in the code lab for you to run, Docker push with the URL of your image. That'll push it to container registry and you will see it there. So next step here is to kick off a training job. And just a reminder that all of the things that I'm showing you within the Vertex AI UI here in the console, you can also do any of these things programmatically. So I'm showing you how to kick off the training job in the console, but you can also use the Vertex AI SDK to write code to automate all of your ML processes, from creating a data set, creating a training job, and kicking off that training job. So the first step is just to tell Vertex AI which data set we'll be using. I'm not going to get into the managed datasets product in this workshop, but if you would like to upload your dataset to Vertex AI via managed datasets, that's what you'll want to do if you want to use AutoML for training. So as you can see here, there's a few different options for training. We are downloading that dataset within our training code, which is why I've selected no managed dataset here. So there's a few different options here, primarily AutoML or custom training. So if you don't want to worry about writing that model code yourself, you can take advantage of AutoML, which uses a technology called neural architecture search under the hood, and it searches across many different model architectures to find the best one for your prediction task. So you don't have to write any of that model code at all. AutoML will handle finding the best model for you. It actually looks like our Docker build may have completed. So let's head back there and see if we can use that. The other option, so if you want to write the training code yourself, which is what I'm showing you in this workshop, you would select custom training on this step. But let's just see if this completed. Hold on one second. It's still cranking here. There we go. All right. So now I'll run Docker push. This should be faster than the build. There we go. Okay, so now I'm just going to go back to container registry to show you that hopefully we see that new image there. Yes, we have this MPG image, which is the one that I just pushed. So now I'll be able to use that image that I just created when I kick off my training job. So the next step is to go into Vertex AI, select training. I'm going to make Cloud Shell a bit smaller because we're going to be using the UI to kick off the training job. And just for those following along with the code lab, we're now on step 5, running a training job in Vertex AI. So we will hit create here. We are not using a managed data set. We are running custom training. So we'll hit continue. We're going to give our model the name MPG. You can give it whatever name you'd like. I'm just using MPG here. We'll hit continue. So when you're working with custom training, there are essentially 2 options for how you want to provide your custom training code to Vertex AI. The first option is a pre-built container. So if we have a number of supported runtimes that give you access to containers that have already been created. So if you want to submit your custom training job in this way, all you need to do is package up your training code as a Python package. And the supported runtimes are for XGBoost, scikit-learn, TensorFlow, and PyTorch. And there's various versions of each of those that are supported. If you prefer to use a Docker container, which is what we're doing here, maybe because your code is written in, you're using a different machine learning framework or a language other than Python, you'd want to go the custom container route. So we will click on custom container here. Let me just make sure everyone can see my screen. Okay, yes, we're good. Okay, so in the custom container settings, we can click browse here and we should see that container that we just pushed. Yes, 2 minutes ago. We're going to select that so that we don't have to paste that container image URL. It's just handy right there in the browser. We are going to leave this model output directory field blank. We would use this to specify a directory where our saved model assets are located. When we deploy our model, just in the interest of time in this workshop, I've made a public version of these model assets available, and we're going to use that to deploy the endpoint, just so that we don't need to wait for the training job to complete. So you'll specify your container image here. You'll want to leave the rest of the fields blank. Step 4 is hyperparameter tuning. In this workshop, we are not going to use hyperparameter tuning, but just a little bit about what that is. If you'd like to have Vertex AI handle tuning your hyperparameter values for you, things like learning rate or the number of neurons in a specific layer in your machine learning model, all you need to do is in your code, you would provide a config file that specifies the different hyperparameter values you want to tune, the range of values you'd like Vertex AI to try for each of those hyperparameters, and the metric that you're trying to optimize for. And using this, this will use Bayesian optimization as the technique for hyperparameter tuning. There's also a couple of other algorithms available. So you can read more about hyperparameter tuning in the docs. We are not going to use that for now. Okay, so now we're going to specify some compute settings for our model training job. Remember when we selected the region for when you created your cloud storage bucket, we used US Central 1, or at least I did in this tutorial. So if you used a different region, that's where you would want to click this drop down and change it to the region that you used when you created your bucket. And now we can specify the compute settings for this training job. There are a lot of different distributed training options available on Vertex AI. The model example that I'm showing you here, it trains really fast. So we're not going to take advantage of distributed training for this. But if you wanted to, you would add more worker pools. So here we're just going to select a standard N1 standard for a machine. We're not going to use any accelerators here. So we're not going to use a GPU for this job. But if you'd like to do that, you can specify that. If you kick off your training job programmatically via the SDK, you can also specify all of these replica count options using the SDK. So if we wanted to run distributed training, we just need to make sure that we had specified a distribution strategy in our training code with whatever framework we're using. We would then choose how many worker pools we wanted to be allocated for this job and whether we wanted to add an accelerator to any of those worker pools, like a GPU. As I mentioned, just to keep things simple, in this case, we're going to just use one worker pool with an N1 standard for machine. And then last step, so as I mentioned, you don't need to use Vertex AI for training and serving if you only want to use it for one piece. So one example, maybe you have a very computationally expensive training job and you want to take advantage of the cloud for running that, but then you want to download the resulting saved model assets and deploy that, run it in an on-device environment. You can absolutely do that. You can also, maybe your model trains really fast and you'd like to just train it on your laptop, but then you want to deploy it to the cloud to use online prediction or batch prediction. You can do that as well. So we're going to leave this prediction container option blank. As I mentioned, I wanted to show you how to kick off a training job in Vertex AI. When we deploy this model to an endpoint, we're going to use a version of the saved model assets that I already have available. So with that, we will click Start Training. And we should see this training job kick off here. So we can monitor this training job in the console. And after the workshop, I encourage you to go back and take a look. When the training job completes, it should write the TensorFlow saved model assets to the storage bucket that you created at the beginning of the workshop. So you're welcome to go back and look at that. You can also go take a look at the logs for the training job as it's running. So with that, we are going to move right along to the next step of the lab. So this training job should take about 15 minutes to complete. So again, when it's done, you can go back and check it out. You can even deploy a new model using the model assets that were created from your training job. But just in the interest of time, I've made these model assets available in a public cloud storage bucket for you. So if you're following along with the Code Lab tutorial, make sure you are on step 6 at this point. Next, we are going to be getting back to Cloud Shell. We're going to be creating a model. In Vertex AI, we have the concept of model resources, and a model can be deployed to an endpoint. The endpoint is what you would use to get online predictions, which is what we want to do. So we will make our Cloud Shell a little bit bigger because we're going to be using that for the next steps of this lab. So let me just clear that. Okay, so next step is we want to install the Vertex AI SDK. So I'm grabbing the pip3 install command from the Code Lab. And we can use this SDK to do all sorts of things in Vertex AI. We can use it to create data sets, and I just want to make sure I've installed the latest version correctly. Looks like I have. We can create data sets, training jobs, deploy models, get predictions, get batch predictions, lots of things that I haven't listed there. And you can take a look at the docs if you want to learn more about how to use the SDK. In this case, we're going to be using the SDK to create a model and deploy that model to an endpoint. And so to do that, we're going to head back to the editor in Cloud Shell. And I'm going to just copy this code before I do that. So we'll want to go back to our editor. And we don't need this. We're not going to be using the MPG directory now since we've already run our training job. We will want to create a new file, which we can do via this file menu. And we're going to call this deploy.py. Okay. So you should have a file that looks like this. Let me just make it a bit bigger so you can all see what I'm doing in here. Okay, so in this file, you want to paste that code that is in step 6 of the tutorial. And what this is, you don't need to make any changes to this. This is going to upload your model and then deploy that model to an endpoint. So we're just importing the Vertex AI SDK. That's what this line is doing. And then here we're using it to upload our model. Here, notice we have this artifact URI parameter that we've passed. These are the public model assets that I've made available. So once your training job is done, if you'd like to create a different version of this model, all you need to do is change the artifact URI to your own bucket and make sure that the directory you provide is just the directory where you have your saved model.protobuf file. So you can absolutely go try that after this with your own saved model assets. And then if you remember when we went through the training steps, we had the option to specify a prediction container. We said no prediction container. In this case, we're specifying it here. So just like for training, how there was an option to use either a pre-built or custom container, we have the same options for model prediction on Vertex AI. We can use a pre-built or a custom container. So for serving our model for this lab, we're going to use a pre-built container. We're using this TensorFlow 2.3 image, which is available from Google Cloud. We could also create our own container for serving. And one of the benefits of that would be if we had any pre or post-processing code that we wanted to run. So maybe, let's say we have a text model, we're doing some NLP, maybe text classification, and we want the client to be able to send raw text to the model, but our model obviously needs that in a different format, maybe word embeddings, a numerical format. So in our container, we could handle transforming that raw text input into Word embeddings. And then if we wanted to do any post-processing on the output, we could do that in our custom container as well. To keep things simple for the purposes of this workshop, we are going to use a pre-built container. And then once the model is created, we're going to deploy that to an endpoint. The only parameter we need to provide here is the machine type that we want that endpoint to be on. And one of the cool things you can do in Vertex AI is you can split traffic between different models. So maybe you want to roll out a new version of your model incrementally to a small subset of your users. This is where you would specify a traffic split. So maybe you only want to serve one model to 5% of your users and serve a different version to the other 95%. You could specify that here. So once you've saved this file, again, you don't need to make any changes to it. You will go back to the terminal. And we want to make sure we are one directory up. So not in our MPG directory. Just make sure you're in the directory where that deploy file you just created is. Okay. And then the next thing we're doing is we're just running that deploy file and we're piping the output to a text file, which we'll use when the endpoint deploy has completed to grab the URL of our deployed endpoint and copy that into our prediction file. So that will take probably about 10 minutes to deploy, but don't worry, I've got a version that's already deployed for me to show you and for us to try out. So I'm going to make this a bit smaller. As you can see, if you go back to your editor, you should see this deploy output file created, which is logging the output of that command to this file. That's what the T did in the command. So let's minimize this. We'll go over to our models. If we hit refresh, we should see that a new model was just created, and we want to click on that, and we should see a pending endpoint deploy, which we do. So that's a good sign. So once this endpoint is deployed, we can use it to get online predictions. Let me just make sure everyone can see the screen okay again. Looks good. So while we're waiting for that endpoint to deploy, I'm going to show you an example with a version that I have already deployed. So if we go back to our models page, we see the saved version, and we see an endpoint that has been deployed. And so the next step in the lab is to finally get a prediction on your deployed endpoint. So that was the goal of this workshop, teach you how to train a model, deploy that model to an endpoint, and then finally get a prediction on that model. So next step is to create a file called predict.py. So let me just copy what's going to go in there. So we're back in our Cloud Shell editor. File, new file, we want to go predict.py. And we see that file created here. And we'll want to copy the code from step 6 into this file. So let's just look a little bit at what's going on here. So again, just like when we deployed our endpoint, we are importing the Vertex AI SDK. And the next thing we're doing is creating a reference to that endpoint. Here it just has a placeholder endpoint string. In the lab, you'll see instructions for how to update that with your specific endpoint string once it's finished deploying. Next, we have a test example that we're going to send to our model. This test example has already normalized data. So this has been normalized, so it's in the format that our model is expecting. The output that we're expecting is a predicted fuel efficiency value, miles per gallon. So that's our test example. All we need to do to get a prediction via the Vertex AI SDK is just run this endpoint.predict with that test example, and we're going to log the response and just the actual miles per gallon value to the console. So let's check on the status of our endpoint. Go back here. Okay, looks like it's still deploying. So in that case, we're just going to use the version that I have ready to go, which is this predict save file. So as you can see, this has the URL of, I believe, the endpoint that we're looking at here. Yes, you can see that this ID matches the one here. So we're creating a reference to that endpoint that I've already deployed. And then we're just going to run that to get a prediction on our model. Once your endpoint deploy completes, just make sure that you go back to the lab. There is 2 commands that you need to run, just some sed commands that will replace this endpoint string placeholder with the string of your endpoint. So don't forget to run those 2 commands, otherwise your prediction will not work. So we are ready for the final piece of this, which is getting a prediction. So all we're going to do is back to the terminal. I'm just going to open a new tab and make sure I'm in the right directory. Yes. So I'm going to run Python 3 predict saved.py. This should ping my deployed model, which it just did. And good news is we have a prediction. So for this particular input, our model has predicted that based on these car metrics, the predicted miles per gallon is 16.3 roughly. So just to recap all of the things that I've demonstrated here, we started by enabling these services, packaging up our TensorFlow model training code into a Docker container, pushing that container to container registry. Then we used Vertex AI to train our model, pointing it to that container registry image. And then we deployed it to an endpoint and finally got a prediction. As you can see, was able to do all of that in under an hour. And again, the cost of this was just about $2. It's important so that you're not charged for this endpoint, assuming that you don't want to use it when you're done with this, is that you undeploy it. And you also want to delete that storage bucket that you created. So instructions for that are in step 7 of the lab. So that basically concludes the lab. If you have any questions, definitely use the Q&A feature. Since we do have a little extra time, I will tell you a little bit more about Vertex AI. So if we could go back to the slides where I left off on those. Okay. Yeah, so just to give you a little overview on Vertex AI and introduce you to some of the features that I wasn't able to cover in this live workshop. So again, at a high level, what is Vertex AI? Vertex is a managed machine learning platform for practitioners to accelerate experiments and deploy AI models. So what does that mean? As you saw, it's an end-to-end machine learning platform. So it's designed to support you through each step of your ML process and provide a unified environment for doing that. So no matter what tool you use for model training, all of your models will show up in the same place, along with all of your endpoints, and you can use the same API, the same SDK to access all of those machine learning resources. And again, this was just announced yesterday, so you can be one of the first to try it out. Just to give you a little bit of background and set some context for where Vertex AI fits into a typical application development workflow. So as you may have guessed, Vertex AI sits at your application backend and provides this end-to-end complete platform for machine learning, model development, deployment, and monitoring. So you would then probably have Vertex AI. You'd probably have your application logic. Let's say you wanted to build an application that serves predictions to end users. In that case, you would have your application logic communicate with your deployed model in Vertex AI if that's what you wanted to do. So just as we did, that code that you just saw, the prediction code to call our deployed model endpoint, that would be maybe your application logic talking to Vertex AI, and then you would surface that prediction to your end users. This doesn't describe every use case, so maybe you only want to generate batch predictions on your model. You can absolutely create a batch prediction job in Vertex AI, either through the API or right in the UI. So we saw just a few pieces of Vertex AI demonstrated in this workshop, but this slide is just meant to give you an overview of all the different parts of Vertex that are included. So it takes you from all the way from gathering your data that you're going to use to train your model, tools to help you with feature engineering, hyperparameter tuning, training, serving your models, and monitoring those production models to make sure that they are staying accurate. In this lab, we focused on the training and prediction services. So you can use Vertex AI for your entire machine learning workflow if you'd like. You can use it to upload your data, train your model, scalably deploy your model to an endpoint, and you can also use it to streamline workflows with pipelines. So some new products that are available in Vertex AI can help you with ML ops, which is the process of productionizing, standardizing, and making your machine learning workflows reproducible. And we have many different products to help you with that, from pipelines to model monitoring to feature store. We have documentation and blog posts for you to learn more about that. I touched on this during the workshop, but just to reiterate, Vertex AI supports both UI-based model development and code-based development. So whichever you prefer, if you'd like to go into the console to kick off your model training jobs, you can absolutely do that, but you can also use the SDK. We saw a little bit of both here. We used the console to create our training job, and then we used the SDK to create our model and deploy that model to an endpoint and get a prediction. And this is just an exercise that I use when I'm working with customers and external folks to help them figure out the right tool to use for their machine learning job. So once you've identified that you want to use machine learning for a particular task, the next question that I'll typically ask is, do you have your own training data? If the answer is no, we have a set of pre-trained APIs for you that give you access to pre-trained machine learning models that have already been trained on lots and lots of data. So all you need to do is pass it some data, and works just like simple REST API, and you'll get some analysis back. So this is a great choice if you want to perform a common machine learning task, maybe by analyzing what's in an image, getting the sentiment of text or translating text. We have a number of different REST APIs to help you do that if you don't have your own training data. This workshop assumed that you did have custom data that you wanted to use to build a machine learning model. So train your own custom model. So if the answer to the first question is yes, then the next thing you want to think about is whether or not you're writing that model code yourself. And the summary here is that whether or not you are writing that code yourself, we have tools that can help you on Vertex AI. So it does support varying levels of machine learning expertise. So if you don't want to worry about writing model code, you can use AutoML for training, which I didn't show in this lab, but I do have another lab that shows you how to do that. And then if you are writing the model code yourself using frameworks like TensorFlow, PyTorch, XGBoost, Scikit-learn, or any other framework, as we saw, there's lots of tooling available to support building custom models on Vertex AI. So that's the path we took in this workshop. A little bit more about AutoML training. So AutoML gives you access to state-of-the-art machine learning models in less time and doesn't require you to write any model code. And when your model is done training, you get access to detailed evaluation metrics. And for certain data types, you also get access to feature attribution. So this tells you the signals that influenced your model most in making a prediction. Various data types are supported for AutoML, including image data, video data, text data, and tabular data. I showed you how to do custom training. So you can train models with a framework of your choice using custom containers, or you can use one of our pre-built containers. You can run distributed training jobs and accelerate your training via GPUs. And you can also make use of hyperparameter tuning, which I talked about a little bit. Then, as we just saw, we can scalably deploy your model to an endpoint. And whether you train your model with AutoML or custom model code, all of your endpoints show up in the same place, and you can access them with the API that I just demonstrated. You can split your traffic between models, and you can also customize the machine type on your endpoints. As you saw, I passed that parameter when I created the endpoint via the SDK. So that's all I got for today. Thank you for joining. Thanks to the TAs for helping answer questions. If you want to get started, cloud.google.com/vertex-AI. If you want to dive into documentation and start building your own custom models with Vertex AI. And then one more thing, just want to plug some upcoming events, opportunities to learn more about all of the tools that I covered today and some that I didn't get a chance to cover. We have the Google Cloud Data Summit coming up on May 26th, and the Google Cloud ML Practitioner Summit, where I'll be going more in depth on some of the features that I covered in today's session. That is on June 10th. And you can register via the link on the slide. So encourage all of you to check that out. So thanks everybody for watching, and I hope you enjoy the rest of Google I/O.